Hello my dear students, in this video we will study the binding energy curve, the average binding energy of the nuclei. So let us draw a graph between average binding energy and the mass number. First of all, I will like to tell you what is the average binding energy. Let us say the total energy of the binding energy of the deuterium is 2.2 MeV. So its binding energy will be equal to 1.1. That is, it has got two number of nucleons in case of deuterium. So its average binding energy is 1.1 MeV, million electron volt. So average binding energy is obtained by dividing the total binding energy of the nucleus by the total number of nucleons. That is known as the average binding energy. If we plot a graph between mass number and the average binding energy, we get a curve like this way. This curve indicates very interesting things. You can see that is there are some peaks for in this region from 0 to 30 mass number, and again we have the maximum energy for iron 8.8 MeV. Then this energy average binding energy steadily goes on decreasing, and finally for uranium 238 it drops to 7.6 MeV, million electron volt. So let us see what are the main features of this curve. So for mass number 30 to 170, ये 170 के आसपास हमारे पास यहाँ आ जाता है ये मास नंबर, और यहाँ ये 30 है. तो 30 से लेकर 170 तक जो बाइंडिंग एनर्जी कर्व है दैट इज ऑलमोस्ट कांस्टेंट. एंड द सेकंड फीचर इज दैट फॉर मास नंबर ए लेस देन 30 पीक्स हमारे पास ये आई हुई देखिएगा. दीज आर द पीक्स. दिस इज 1H1 हीलियम, कार्बन, ऑक्सीजन एंड सल्फर. These peaks indicates the higher stability, and this H2, H3, 1H1, 1H3 isotopes of hydrogen, they represents the binding energy per nucleon is very small. इनके लिए binding average binding energy small है. यहाँ पर जो peaks है, peaks indicate कर रही है कि जो यहाँ nuclei हमारी होंगी those are more stable. And this lithium जो यहाँ पर हमारी dots है नीचे की तरफ, ये लिथियम है, नाइट्रोजन है, ऑक्सीजन, नाइट्रोजन एटसेट्रा, दीज हैव गॉट less stability. So the important conclusion number one, listen very carefully. Most of the students do not understand it very easily, but I will make it very easy. If somehow the nucleus is splitted into small size nuclei, each nucleus will have more binding energy per nucleon than the original one. For example, in case of uranium, if somehow by the bombardment of alpha particle thermal neutrons, if we split the uranium 235 nucleus, then what will happen? We will be getting the two medium sized nuclei, and the binding energy of those daughter nuclei will be, you look it very carefully, binding energy per nucleon will be more than the original one. जो हमारे पास fragments होंगे after the bombardment of the uranium nucleus, daughter nuclei जो होंगी उनकी binding energy ज़्यादा होगी, और वो जो energy है that is released in the फॉर्म ऑफ बाइंडिंग एनर्जी पर न्यूक्लियन. आप उसको समझ लीजिएगा. बाइंडिंग एनर्जी डिफरेंस फॉर न्यूक्लियन फॉर यूरेनियम 235 इट इज 0.8 MeV. दिस इज द एवरेज बाइंडिंग एनर्जी पर न्यूक्लियन ऑफ यूरेनियम 238, एंड द टोटल नंबर ऑफ nucleons in uranium is 235. So if you multiply this 0.8 MeV by 235, you will get 188 MeV, million electron volt. This is the very large amount of energy, and this energy is released as the binding energy. तो ये binding energy आप कैसे define करेंगे? The amount of energy required to separate the nucleons from the nucleus. So in case of the first important thing comes out to be, that is in case of the this binding energy when it is 7.6 MeV, these nuclei are less stable. Less stable क्यों है? क्योंकि इसके अंदर जो कोलम्बियन फोर्स है प्रोटॉन्स का वो ज़्यादा डोमिनेटिंग हो जाता है. सो दैट इज व्हाई दिस न्यूक्लियाई आर less stable. So the first importance or conclusion of this binding energy curve is that for the nuclei which are having large mass number, that is the binding energy is very high. If some, I may repeat कर रहा हूँ, सुन लीजिएगा. If somehow the original nucleus is broken into parts, small size nucleus, then each new nucleus will have more binding energy per nucleon than the original one, and that energy difference is emitted during this process, that is known as the nuclear fission. इसको nuclear fission बोलते हैं, and it is the basic principle, that is nuclear fission. When a heavy mass nuclei is broken into parts, the binding energy of the each nucleus is very large in comparison to the original nucleus. That is the principle of nuclear fission. Then we come to the second characteristic, that is in case of the light nuclei, the joining two lighter nuclei gives a medium sized nucleus. The new nucleus has more binding energy per nucleon. यहाँ पर हमारे पास ये लाइटर न्यूक्लियाई है जहाँ पर मास नंबर कम है. सो द प्रोसेस इज that is this nuclei when combined together, what happens, a medium sized nuclei is formed. The binding energy of the new nucleus formed as a result of the fusion of the lighter nuclei is more than the original one. हमारे पास ये प्रोसेस हो रही है इन द सन्स इंटीरियर. टेम्परेचर इज वेरी हाई, टेम्परेचर बहुत ज़्यादा है इन द इंटीरियर ऑफ द सन, और वहाँ पर जो हमारा हाइड्रोजन है that is present in the form of nuclei, and you know that nucleus has got positive charge, positive and positive repel each other. So how do they combine? Because the temperature is very high, the kinetic energy of each nucleus is more than the Coulombian force of repulsion. So therefore they fuse together to give somewhat heavier nuclei, medium sized nuclei, and the binding energy of that very new nucleus is more than the binding energy of the original nuclei which we have taken. That is the principle of the nuclear, you can say, fusion. So in this process 1s2 plus 1s2, ultimately you will get the 2He4 and 23 MeV energy is released. This is the possible region of the nuclear fusion and the main source of the energy of the stars. We are getting energy from the stars by thermonuclear reactions. Now perhaps this Fe56, it is the most stable state in the case of the elements, and that is why the evolution of the universe takes place directly or indirectly from this process of the nuclear fusion and fission. That is, there is no further higher energy known than this energy of the average binding energy 8.8 MeV per न्यूक्लियन ऑफ द आयरन. आयरन की जो एवरेज बाइंडिंग एनर्जी है वो सबसे ज़्यादा है. इट इज़ द मोस्ट स्टेबल. स्टेबिलिटी यहाँ के रुक जाती है. सो दैट माइट हैव बीन द पॉसिबल रीजन डायरेक्टली और इनडायरेक्टली द एवोल्यूशन ऑफ द यूनिवर्स. सो दिस इज़ वेरी इंपॉर्टेंट टॉपिक फ्रॉम द एग्जामिनेशन पॉइंट ऑफ व्यू. इसमें जो पूछा जाता है आप ये ग्राफ ड्रा कीजिएगा. यहाँ ध्यान दीजिएगा जो मैक्सिमम पीक है वो 8.8 MeV पर है और लास्ट में यूरेनियम है दैट इज 7.6 MeV है. वो कैसे है? लेस स्टेबल है और हैवियर न्यूक्लियाई है. ओके, एंड देन यू हैव द न्यूक्लियर fusion. Fusion is the process of combining the two lighter nuclei to form medium sized nucleus, and in this process a large amount of heat is evolved, that is equal to the binding energy. जहाँ पर binding energy is defined as the energy required to separate the nucleons from the nucleus. Thank you very much for watching the video.